You know, when you see a piece of gold, a ring, a coin, have you ever really stopped to think about where it came from? I mean, really came from. We're going to take a look at the incredible journey from a chunk of ordinary looking rock to a bar of pure, gleaming gold. It's a wild story of industrial chemistry. So, let's start with the central problem, right? You're looking at tons and tons of rock, and somewhere in there is gold. But it's not like you think. There are no big, glittering veins you can just chip out. No, we're talking about microscopic particles, totally invisible to the naked eye. So how on earth do you get it out? Yeah, forget those old movie scenes of a prospector striking it rich with a pickaxe. That's not how it works on a massive scale. The real magic, the heavy lifting, it all happens at a molecular level. The answer isn't a tool, it's chemistry. Okay, so where do we even begin? Well, before we can do any cool chemistry, we have to prep the material. It's all about getting access to those tiny little gold particles that are trapped inside. Think of it this way. It's kind of like trying to get sugar out of a sugar cube that's stuck inside a rock. You can't just dissolve it. First, you've got to break everything down. So these massive chunks of ore get fed into these absolutely giant mills that just crush and grind them down into a super fine powder. And this is a crucial step because it frees up the gold from the mineral prison it's been locked in for millions of years. All right, now for the part that sounds a little bit like science fiction. We're going to take that solid microscopic gold powder and turn it into a liquid. This whole process is called leaching. So what you're looking at here is the whole circuit. That rock powder we just made gets mixed with water, creating this muddy mixture called a slurry. And that slurry gets pumped into a series of enormous tanks, which is where the real action is about to happen. So what's going on inside those giant tanks? Well, first, they thicken up the slurry and add some lime to get the pH just right. Then, into the tanks it goes, and this is where a very special and, frankly, very toxic ingredient is added: cyanide. Then they bubble air through the whole thing to get oxygen in there, and giant agitators just stir it and stir it and stir it. So here's the chemistry behind the magic. That cyanide solution, with a little help from oxygen, is super specific. It targets and dissolves the solid gold particles. They don't melt. They chemically dissolve right into the water. So what you've just made is basically a highly valuable, but yeah, also highly toxic gold tea. And this isn't some quick brew. No way. That slurry has to churn around in those tanks for at least 48 hours. That's 2 straight days of nonstop mixing to make sure every last possible bit of gold gets dissolved. Okay, so we did it. Our gold is now floating invisibly in our tea. The big question is, how do we get it back out? Let's start with the classic method, which, believe it or not, uses another metal: zinc. This whole process is called cementation, and it's a really clever chemistry trick where you use one metal to basically kick another one out of a solution. So first, that gold-bearing liquid gets filtered like crazy to remove any solids. Then it's deaerated to pull all the oxygen out. And then comes the key ingredient. Zinc powder is dumped into the solution. Now, chemically, zinc is way more reactive than the gold is, so the zinc essentially tricks the cyanide, bumping the gold out of the way and taking its place. This forces the gold to become a solid again, and it falls out of the solution as this dark, heavy sludge. Now, that zinc method, it works. It's a classic for a reason. But modern plants have an even more efficient, a more elegant solution. And it involves a pretty amazing material that acts like a sponge, but for gold. We're talking about activated carbon, and it's often made from something as simple as coconut shells. They're heated in a special way that creates this incredible, complex network of microscopic pores, and all those pores give it a gigantic internal surface area, turning every little granule into a chemical supersponge that gold just absolutely loves to stick to. So how big are we talking? Get ready for this. A single gram of activated carbon, that's about the weight of a paperclip, has an internal surface area of around 1,000 square meters. That is the size of 4 tennis courts, packed into something you can hold on your fingertip. It's absolutely insane. And that's why it's so incredibly good at grabbing that dissolved gold. So how do they use it? In a process called carbon impulse, or CIP. And this is genius. The gold-bearing slurry flows through the tanks in one direction, while the little carbon sponges are moved in the opposite direction. This creates this beautifully efficient system where the freshest carbon meets the weakest gold solution, making sure every last bit gets soaked up. And hey, you don't have to take my word for it. The data speaks for itself. Look at this graph. The dashed line is the gold in the slurry. See how it just plummets as it goes through the tanks? And the solid line? That's the gold on the carbon. It just goes up and up and up as it soaks up all that treasure. It's perfect. So let's just recap real quick. We've got two main ways to get our solid gold back. The old school cementation method uses zinc to make a sludge, but you have to do a ton of filtering first. The modern CIP method uses those amazing carbon sponges to pull the gold right out of the slurry itself. And that's the game changer. It skips a whole massive, expensive step of filtering and dewatering. We're in the home stretch. We've got our gold back, either as a sludge or stuck to these carbon granules. But it's not a gold bar yet. For that, we need to bring the heat. It's time for the final, fiery step. Okay, first, if we used carbon, we have to get the gold off. That's done by stripping it with a hot caustic solution. Then, that super concentrated gold, or the sludge from the zinc process, gets tossed into a furnace and smelted at insane temperatures. All the other junk just burns away or separates out, leaving behind nothing but pure molten gold. And that, of course, gets poured into molds and cast into those iconic bullion bars. And just like that, after all the crushing, the dissolving, the capturing, and the smelting, that incredible journey from a simple piece of rock to a bar of pure gold is finally over. When you think about it, it's just an incredible amount of science and engineering and pure energy, all just to extract this one single element from the earth. Looking at this whole hugely complex process, it really makes you stop and think, doesn't it? What does all this effort say about what we as people truly value?